Hello students, this question is taken from test series 10 EE from the subject power system from the topic insulators, and it is of 2 marks question. The given question, in a transmission line each conductor is at 20 kilowatt, which is nothing but transmission line. Each conductor is having 20 kilovolts voltage and it is supported by string of 3 suspension insulators. It is supported by 3 suspension insulators. The air capacitance between cap-in junction and tower is 1/5 of the capacitance, which is given the value of K, that is 1/5 of the capacitance value of each insulator. Effective only over the line insulator unit is fitted so that voltage on the 2 units nearest the line N are equal the voltage on the line N units, which is nothing but the given is effective only where the line insulator unit is fitted so that voltages on the 2 units, that is 2 units are equal, that is the 2 units are equal, that is V2 value is equal to the V3. So then the voltage on the line N unit is, we have to find the voltage at the line N. So given voltage is having the 20 kilowatts for each conductor. This is the diagram. This is the current direction I1. This is the voltage V1 and V2, here I2, and this is the value of Cx, that is the current flowing through here is Ix, and it is like short circuited from Cx to here C, and the value of this is supported by C/5. This is the current flowing through here is IC1 and here the current flowing through here is IC2. So we have to find the value of voltage, that is V3. So first we will calculate the value of I2. From here, if you apply the KCL here, that is the current flowing through this one is I2, entering the node is equal to the leaving the node. Here I2 current is entering the node, I1 and IC1 are leaving the node. So if you apply the KCL here, I2 is equal to I1 plus IC1. The value of I2 here is nothing but the current I2 is having flowing to the capacitor. So it will be V voltage into omega C. The voltage here is V2. So from here to here the voltage is V2. So V2 omega C. Then I1 is flowing through the capacitor C. Then here the voltage is V1, that is V1 omega C. Then the IC1 current here, that is the voltage here is V1, and here K into omega C, that is C/5. K into omega C. From here, if you simplify this one, that is V2 is equal to V1 into 1 plus K. How it become, no? V2 omega C is equal to V1 omega C plus V1 K omega C. From here, omega C, if you take common, it will cancel on the both sides. Then V1 plus V1 K. From there, you can take common V1, you will get 1 plus V1 into 1 plus K. That is V1 K. The value of K in the given question, that is 1/5 of the capacitance, that is 1/5. So V1 into 1 plus 1/5. If you substitute this value, you will get the V2 as 6/5 V1, that is the value of V2. And they are given the condition, it is effective only the line over line insulator, that is the voltage on the 2 units nearest the line is equal. So the value of V2 is equal to the V3. So here if you simplify this value here in the second node, that is the apply the KCL in this node, that is K I3 and the current Ix is entering the node and I2 current and IC2 current leaving the node. So if you apply the KCL here, I3 plus Ix is equal to I2 plus IC2. So the current I3 is having the voltage of V3 omega C plus Ix, that the voltage here is V3 into omega Cx. Here the capacitor is Cx, that is the I2 here is the voltage here is V2 into omega C plus IC2. Here the voltage is V1 plus V2 into K omega C. After simplification, you will get the value of for simplification, that is the value of V3 is nothing but V2. After simplification, you will get the value of Cx as V1 plus V2 by V2 into C by 5, which is nothing but, here the value of V2 is 6 by 5 V1. From here you can simplify the value of V1 is equal to 5 by 6 of V2. Then we know the value of V1 and V2. Simplify that value of V1 and V2, that is 5 by 6 V2 plus V2 by V2 into C by 5. After simplification, you will get the value of Cx as 0.367 C, which is the value of Cx. We have to find the value of voltage at the line end. So that is the value of V2. The V2 is nothing but V3. So the value of total voltage, that is V, is equal to V1 plus V2, that is 2V2, that is V1 plus V2 plus V3. Here V2 is equal to V3, then the value of V2 is 2V2 plus V1, that is V1 plus V2 plus V3. Here V2 will become V2, then it is 2V2 plus V1. So the value of V2 we know, and the value of V1 also we know. Then after simplification you will get the value of V as 2 plus 5 by 6 V2. So from here the value of V2 is equal to, in order to find the value of V2, 6 by 17 into V. So the value of V in the given question, that is 20 kilovolt, that is 6 by 17 into 20 kilovolt. That is, after simplification you will get the value of voltage, that is V2 is equal to 7.059, that is at the voltage at the line end, which is the option D. In this session we have studied about how to calculate the voltage on the line end units. Thank you.